Okay, so I think I want to start from here. Okay, so we have this equation. See this equation and the meaning. This one, I thought about this meaning. Okay, so I think I want to start from here. Okay, so we have this equation. So let me see. I can go to whiteboard. Uh, so you have some object or like point. So then you have a spatial coordinate like this: x1, x2, x3. Then you actually have other observer coordinate. So which one is observer coordinate? That's a question. Maybe okay, x prime is observer's coordinate, I think. Okay, let's see. So we have observer's coordinate, something like this. Okay, so we can say something like x1 prime, x2 prime, x3 prime, yeah, and origin may be O prime. So original origin is O, just O, maybe. Okay, so then you have some object, right? So then the point is this observer coordinate. Observers observers coordinate is moving and moving like according to BT and rotating. So the rotation is given by Qij. Yeah, so this whole coordinate, observer's coordinate, is rotating and also moving. This origin O0. O0 is moving. O dash. I'm sorry. O prime, not O0. O prime is moving. And then at the same time, coordinate is rotating. So there is a relation between the x. X is the original spatial coordinate. This is unprimed. Here I can say this is unprimed. And this coordinate is primed. We have unprimed coordinate and primed coordinate. And primed coordinate is moving and rotating relative to unprimed coordinate. Then we are looking at the same object. This is the object we are looking at. So then this primed coordinate is actually related to unprimed coordinate by this equation. Okay, so because the observer can move and rotate, observer XYZ axis can rotate and move. And this movement, this doesn't have to be linear. This can be just can be a curve. Okay, it's not doesn't have to be line. So I think that's it. Then the distance relation. This is like infinitesimal relation. Infinitesimal distance is actually conserved, even if the other coordinate, even if the primed coordinate is moving and rotating, the infinitesimal length, the length is conserved like this. So here we don't consider deformation. Okay, so we have a primed coordinate is not deformed from unprimed. It is not deformed. It's prime and unprime. This relation is no deformation. No deformation. I can say there is no deformation between primed and unprimed coordinate. There is a rotation and translation. And translation doesn't have to be linear. It can be curved shape. So that this infinitesimal segment is preserved. So infinitesimal length or distance doesn't change between primed and unprimed coordinate. Then this rotation has such relation, like because this is orthogonal matrix. Then we derived this one already, right? Then next one is also some subtle point, including here, including a constant shift in time. We define two motions, x prime, x t prime, x prime, t prime, and xj, xj, t. We define these two motions as objectively equivalent. Objectively equivalent. Is interesting word, right? Objectively equivalent. Two motions. Two motions are objectively equivalent. So how do you understand? Two motions are objectively equivalent. If this equation is very much similar to the objective observer's equation above. See, the funny thing is here, this is J, okay. This is okay, J, okay. the relation between velocities shows that velocity components are not frame independent. What was frame independent? I think there was a definition before. Eh? Was there a definition before frame dependent? Frame independent. Frame indifferent. Indifferent. Quantity that are invariant under observer transformation are called frame indifferent. Other terms for this concept include objectivity and observer independence. Okay, so then the velocity is not frame indifferent. I think because you have this term. So this term, if you have this term, it is not frame indifferent. Differentiating again, we have the acceleration. A prime is qij, aj, q dot vi, qw dot ij, xj, b dot bi dot, which is again not frame indifferent. Yeah, because you have this. So because you have this term, you have this term and this term. So if you don't have these terms, this is a frame indifferent. But because you have these terms, this is not frame indifferent. Objective tensor would follow the transformation law for tensors under objective coordinate transformation. That is, A is objective. See, this is a definition of objective tensor. Objective tensor is such tensor as those that follow this relation. So now you don't have this beta, BIs, BIT. This time you don't have. So it's kind of, I don't know. Anyway, objective tensor is something like this. using the relation, this one, we can write the velocity gradient which is not objective as well. How do you get this? Okay, I can say, let me work out this one. So we go to see partial k vi, partial vi prime, partial xk prime, and then we have to put vi, for example, because we want to change this to prime coordinate, unprime coordinate. Should put vi. Should I put vi? Vi, maybe. Qij vi is like this. Partial xk prime qij vj xt q dot ij xj q dot ij xj xt plus bi dot. Yeah, so then let me see. We want to eliminate partial How do we handle it? How do we handle it? I don't understand. very difficult. How do you understand this word? It seems like this differentiation act on here and here, but not here. Doesn't act on here. Right? So then yeah, I have some hard time understanding this. Let me see. Let me think, and maybe let me discuss with someone who is my friend.